All right. For this one, I would like to find the force on this mass A. Okay. So the of course the force is going to be to the right. It's going to be attracted to both B and C. Right. So the force of B on A, okay, is going to be 6.67. The formula I'm using here is G m1 m2 over r squared, right? So 6.67 e minus 11 times 2.6 e6 times 1.8 e6 divided by, and then the distance separating their centers is presumably 6.3 squared. What is that? 6.67 e minus 11 times 6e6 times 1.8 e6 divided by 6.3 squared. That's 7.865 to the right. And then the force of C on A, or the Federation of Christian Athletes, right, is 6.67. I know it's fellowship. I just think Federation sounds cooler. Okay. And then 2.6 E6, because we're going to do A, and then C is 3.7. And this will be, A is attracted to B and to C, right? Gravity is always attractive, just like me. Okay, let's see. This distance is 6.3 and 8.5, right? You got to add them and then square them. Don't be like squaring them and then adding them. Okay, so here we go. I'm so lazy, I'm going to go second entry. And I'm going to change that to 3.7. And then I'm going to change this. I'm going to go left parenthesis 6.3 squared plus 8.5 squared. Whoops. I'm doing exactly what I told you not to do. Okay, hold on. Boom. Betty boom. And then, okay, so 6.3 plus 8.5, the quantity squared. Yes, rather nice. Okay, here we go. That is 2.929 to the right. All right, so that plus 7.8648 is 10.79, 10.8 to the right. Okay, so this, I'm going to make things to the right positive. So that's 10.8 to the right. Ta-da. That's not too bad, is it? All right. So now I'm going to find the force on B. Okay, let's go find the force on this guy. Now, this is going to have a force this way. Okay, the force of A on B, it's kind of fab, will be to the left, and the force of C on B will be to the right. Okay, it's attracted to both ways, right? All right, so here we go. Let's see. Okay, so let's find the force of A on B. Okay, is going to be, and the formula I'm using again is just F is G m1 m2 over r squared, the universal gravitation. All right, so 6.67 e minus 11 times 2.6 e 6 times 1.8 e6 divided by 6.3 squared, and this is going to be to the left. I'm just going to slap a minus sign on there. Okay, and then the only reason that minus sign is on there is because this thing, the B is going to be attracted to the left. The force of A on B will be leftward. So I'm going to slap a minus sign on there so I can add them intelligently. All right, here we go. Let's see if I can find that. See how lazy I am. There it is. There it is. I just found it on my calculator. I'm simply going to hit enter. And it's 7.8649. 7.8649. And that's newtons to the left. I'm putting parentheses around left so that it's not like negative left and then right again. Okay, let's see. And then we want to find the force of C on B. Right, and that will be to the right, definitely. It's going to be attracted to the right, so it's 6.67 E minus 11. So you understand, I just put this minus sign on there because this guy was to the left. That's what I do. You could choose to do it a different way. And then I'm going to go 1.8 E6 and 3.7 E6. That's these two masses, right? And then that's divided by 8.5 squared. So let's see. I'm going to go second entry. I'm far too lazy to. Okay, so here we go. Let me change that to 3.7. Let me change this to 8.5. I think I've got something that'll work. Yeah, I do. I've got them both. Okay, here we go. Ta-da. And that's 6.1484. Positive 6.1484. And that's to the right. And then I can just add them up this way, right? So the net force on B, we just got to add these guys up. So I'm going to go that guy minus 7.8649. I always want to say 8649. All right, here we go. That is negative 1.72 newtons. So I'm also going to say it's to the left. If you leave off the parentheses, I'm never going to interpret negative that to the left as a double negative. I'll just know that you mean to the left. I'm not quite that mean, although maybe I should be that mean.